Okay, I decided to post a couple more examples. I feel like that didn't quite do enough there. You don't have to take notes on these necessarily, but you can certainly try them and then see if you did them right. And I'm going to go through them kind of quickly, but I did feel like I should give you a couple more examples. Okay, so here we go. So the first one, the first three here, I'm going to convert to scientific notation. And so here's the order in which I'd have my students do this, is that when they're going to scientific notation, I have them write down what they know they need to have for scientific notation. So if I'm doing scientific notation, I know that I have to have times 10. All of these are going to have times 10 in their answers, and then times 10. Okay? And then I also know that, like for this one, my number needs to be between 1 and 10. So I look at this and I see that this is 3,146. So that means I need to move this decimal place to right here, the first two non-zero numbers. So my number is going to be 3.1426, like that. Okay? Then the next thing I have my students do is they just tell me what they know about their exponent. So I know my exponent because this original number is bigger than 1. That means my exponent is going to be bigger than 1. Okay? So there we go, like that. And now the last thing they do is they figure out what is the number for the exponent. So that's where it started, and I'm finishing over here. So I went 1, 2, 3, so times 10 to the third. So there's my number, 3.1426 times 10 to the third. Okay? Now looking at the bottom here. Okay, so I've already done my times 10. And I know that this decimal point needs to make this number between 1 and 10. So that means it has to go to right there. So my new number is 3.51 times 10. And then I need to do my exponent. And so for my exponent, what I do is I look at this number, and does this tell me if my exponent is going to be positive or negative? Well, since my original number is less than 1, that means it's going to be negative. And then I figure out how many times I moved it. Well, I moved it 1, 2, 3 times again. So times the -3. Okay, so both of those aren't too bad, right? They're pretty straightforward as far as converting to scientific notation. Now you look at this bottom one down here, and a lot of students are going to look at this and they go, well, it's already in scientific notation because I have times 10 to the something. And they're going to say it's done. But remember, this number needs to be between 1 and 10, and it's not. So I'm going to show you a couple of ways you can do it. One's a little bit more advanced than the other. This one will work for everything. So what I might have my students do first, when this is the problem that they see, the answer that they get, they go, okay, well, let me change it back into standard form first, because that's not in scientific. So let me change it to standard form, and then I will change it into scientific notation. Okay, so then if I'm going to go to standard form, what do I know? Well, I know that this is telling me that my answer is going to be smaller than 1. So, and this is telling me how many times I need to move it. So if I want this number to be less than 1, then I can't move it to that direction. I have to move it towards the front. So I'm going to move it 1, 2, 3, 4 times. So I get 0.00234. Okay? This is not scientific notation. This is standard form. So now I need to change this into standard form. So what I see here is that, okay, it's going to be times 10. I know that. And I know that my number needs to be between 1 and 10, so I need to move it to right there. So that's going to be 2.34. And then I need to figure out, is my exponent positive or negative? Well, I see this number here is less than 1. So that means it's going to be negative. And then I need to move it 1, 2, 3 times. So 10 to the -3rd. Okay? So there's my answer. The answer to this question right here is 2.34, actually 2. I don't know why I left that 2 off of there. You guys probably noticed that already before I did. Should be a 2 in there. 2.342 times 10 to the -3rd. Okay? Now, as you do these a little bit, what some students might realize is, hey, this is 1 too big. So that means this is not the right thing. And so if I move that one spot, that's going to be adjusted by 1. Okay, so there's a way they might be able to do it a little bit quicker than doing this, but this will always work. And I don't really, in particular, have my students worry about going the shorter route until they've done quite a few of these. So for you guys, as long as you can do it this way, that's fine. Okay, now let's take a look at these. So these are converting to standard form. All right, so what I have here is I have it in scientific notation because this number is between 1 and 10 is times 10 to the something. And so what I do is I look at this, and what does this tell me? Well, that tells me that my number is going to be less than 1. Okay, so it's going to be a small number. So if this is where my exponent, or excuse me, where my decimal point is to begin with, which direction do I have to move this so that it's going to be, the final number is going to be less than 1? Well, I can't move it that way because that makes it into thousands. So I'm going to move it 1, 2, 3. So it's going to be 0.003104. And there you go. That's my number. Okay, so there's my final answer right there. I move it this direction 3 times, and I put a 0 in for each of those spots. So 0.003. Okay, one thing I'll just say that at the end. Okay, now number 6 there, or number 5, I mean. You might notice that the, where's the decimal point, right? Well, first of all, is it in scientific notation? Well, it's times 10 to the something. And is this number bigger or than 1 but smaller than 10? Yes, it is. So your scientific notation does not need to have a decimal point as long as the number is between 1 and 10, although we almost always write 6.0 like that in scientific notation. So now, okay, when I'm finished, I need this final number to be bigger than 1. Excuse me, I need this final number to be bigger than 1 because that's a positive. So since that's a positive, this final number has to be bigger than 1. So that means I have to move it that way 5 times. So it's going to be 6, and then I move it 1, 2, 3, 4, 5. Actually, I'm going to write that down here so you can see a little bit better. Okay, so now I'm going to move it 1, 2, 3, 4, 5. Plug in my zeros there. So I end up with 6, 1, 2, 3, 4, 5. So 600,000 would be my final answer on that one. Okay. All right, now look at that bottom one down there. And the first thing you might notice is that we have a negative in front. So how is that going to change this problem? Or is it going to change the problem? Well, it does change the problem a little bit, but not for how we're going to do it. That has no effect on any of the steps I'm going to do. The first thing I'm going to do is I'm going to look at this and say, okay, that my answer needs to be smaller than 1, needs to be less than 1. So the only way, and that, remember, excluding the negative, that doesn't matter. The only way I can make this number here, 2.83, less than 1, is if I move it that direction. So I'm going to move it that direction 4 times. So I've got 1, 2, 3, 4. So I plug in zeros in there. So I'm going to have 0.1000283, like that. Now, the only thing that makes this one different than that one is it's not a positive 0.283, it's a negative 0.283. But that negative has nothing to do with this negative. That negative right there is this fraction of a number. Okay, so I wanted to put one of those in there so you don't get freaked out by all these negatives. That tells me I have a number less than 1. That tells me the sign. Here, the sign is positive, so it stayed positive. Here, the sign is positive, so it stayed positive. Okay? All right, so there's a couple more examples for you. I didn't feel like I gave you quite enough. I'm going to load this up. If you don't need the examples, no worries.